Okay, so today we're going to start on Unit 10.1. Help if I had a good pencil. So again, we are on Unit 10.1, and what we're going to be starting on today, we do have a rather long lecture. It just is this way because there's a lot of different types of things that we're going to go over today. And what we're going to be learning to do is to apply what's called the fundamental counting principle. Okay, and that's principle P-L-E, not P-A-L. Okay, apply the fundamental counting principle. And we are going to deal with something called permutations. Okay, so apply the fundamental counting principle, and we're going to learn how to do something called permutations. The fundamental counting principle is very simple, okay, and it can be used, I want you to keep in the back of your brain that it can be used in many different situations. Okay, so I'm going to show you some of those today. The counting principle says, or it tells us, that if one event can occur in M ways, and another event can occur in N ways. So if one event can occur in M ways and another event can occur in N ways, then the number of ways that both events can occur is M multiplied by N. So if one event can occur in M ways and another event can occur in N ways, then the number of ways that both events can occur is M multiplied by N. So what this fundamental counting principle basically tells you is once you figure out how many choices you have, then you figure out how many, like your first choice, you figure out how many choices you have. Then your second option, you figure out how many choices you have there. You multiply them together. So you are going to see this worked out in a bunch of different ways, but we're going to kind of start slowly. If I want to know, for example, 1, if you have 6 models of cars, okay, 6 models of cars, available in 3 colors. Okay, if you have 6 models of cars available in 3 colors, I want to know how many different, I'm going to say how many distinct cars are possible. The word distinct means how many different possibilities are there. So say, this is super simple, okay? Say we're opening a car lot, okay? And I'm going to carry 6 different models of cars. Each one could come in 3 different colors. And if for like the first day of business, I say I want to have one of every possibility. How many cars would I be ordering? 18. All you really have to do here is take the number of models multiplied by your second option. So your first option is the models, so that's 6 models, multiplied by the second option is your colors. Multiply them together, 18 is your answer. And that's it. Okay? So essentially the fundamental counting principle is just taking the number of options and multiplying them together. Okay? Should be fairly simple. Let's try another one for number 2. Okay, how about if I give you 3 different pizza crusts? 3 different pizza crusts. Doesn't really matter what they're called, but just know that there's 3 different pizza crusts. There are 2 different sauces and 8 kinds of toppings. Okay, given 3 different pizza crusts, 2 different sauces, and 8 different toppings. I want to know how many possible one topping pizzas are there? So if you get someone that's trying to be funny, like, oh, they call up and they say, I'm going to order one of everything. One of everything you can do. How many different pizzas would they be ordering? A lot. Yes, thank you. Now, keep in mind these are one topping pizzas. For whatever reason, my pizza place only does one topping pizzas. You cannot have two toppings. It can only be one. My workers can only handle one topping. That's it.
They're all Jimmy's.
Okay, so all you really have to do is multiply your options. Okay, so how many different crusts do I have? 3. Multiplied by how many different sauces do I have? 2. Multiplied by how many different toppings do I have? 8. Multiplied together, I have a possibility of how many different kinds of pizzas? 48. So if someone obnoxious calls and says, I want one of everything, you're getting 48 pizzas.
Or 48 toppings.
Nope, you're getting 48 pizzas.
Oh, yeah.
Okay, so the basics of the fundamental counting principle is just multiplying your options together. Okay, so figure out how many options you have. I would draw these spaces, even the ones that are really simple, because it's not always going to be simple things like this. And then multiply them together. Okay, next we're going to move on to, and you're going to have, there's kind of a lot of homework for this because there's a lot of different types of probability and permutations that you're going to deal with today. There are a lot of examples. I believe there's 16. Okay, I want to know how many positive integers, remember, are whole numbers, how many positive integers less than 100 can be made using only the digits, using only the digits 6, 7, 8, and 9. So basically I'm saying how many numbers are there less than 100 that can be made that are only using the digits 6, 7, 8, and 9? Any ideas?
16.
There's not millions. It's less than 100.
What's going to be fractions?
No. Integers. Integers are whole numbers. Okay. Why would you think it's 16?
There's 36 of them.
There's 4 numbers and each can match up 4 times.
Say that again?
There's 4 different numbers and then each number has a couple of options.
Okay. Let's look at it this way. You're on the right track, but not exactly right. Okay. If it's less than 100, how many digits must be in my number? Does it say it has to be 2-digit numbers?
No.
Or 1. So you could have some single digit options. Remember, digit is just numbers. How many different single digit options do we have? 4. You could have just 6, 7, 8, or 9. Okay? 4 different single digit options. But there's also double digit options.
Wait, single? Can you say that again for single digit?
There are 4 different single digit options.
6, 7, 8, or
Okay, 6, 7, 8, or 9. Those are single digits. So there's 4 different possibilities for single digit numbers that are less than 100. But we also have double digit numbers. How many different possibilities are there for the first digit? What am I working with? 6, 7, 8, and 9. So how many different possibilities are there for the first digit? 4. You could have 6, 7, 8, or 9. So there's 4 possibilities. How many possibilities is there in the ones spot? Another 4. 6, 7, 8, or 9. So what am I going to do with all these? If I just was looking for double digit numbers, I could have 66, 67, 68, 69, 76, 77, 78, 79. What am I really doing with these 4s?
Multiplying.
Multiplying them. What do I do with this 4? What do you think? We are going to add it. So basically there are 4 single digit options plus 16 double digit options. So how many total double digit options do we have? 4. positive integers less than 100 can be made using only the digits 6, 7, 8, and 9? 20.
Don't allow us for.
Okay? Answer is 20. Okay? So what you are going to learn here is there are a lot of different options. Okay? This is the gist of what we're going to be doing today. Okay? So there's a lot of this that if you're super great at math, that's fine. But a lot of this unit is going to deal very, very heavily on common sense. Right? And you have to think about it a little bit. So there's not necessarily just a formula that I can give you for a lot of these situations.
I have a question. How much are in my padlock?
Okay, we're going to do these right now. Okay, so for example number 4, I want to know, for example 4, I want to figure out how many license plates made of 3 symbols, and symbols meaning letters and digits. How many license plates made of 3 symbols, being letters and digits, can be made using at least 1 letter can be made? How many license plates made up of 3 digits, or 3 symbols, excuse me, being letters and digits, using at least 1 letter can be made? Not an infinite amount, no. So if I say I'm going to use at least 1 letter, do I have to use 1 letter in my license plate?
Yeah.
Do I have to use only 1 letter? No, I could use 1 letter,
You can use it to 7.
or I could use 2 letters, or I could use 3 letters. But you can't use more than that because remember, I'm only having 3 spots. Okay, so basically I'm making license plates that just have 3 spots. Right? It's possible that I could have just 1 letter. What would be the arrangement if I just had 1 letter? What has to come first? Do I have to put the letter first? No, so I could write letter and then number and then number. Okay, what if I did that? How many different possible letters are there? How many possible letters are there in the alphabet? 26. Multiplied by how many possible digits? How many choices do I have for digits?
9. 10.
Let's think about this.
You have 10.
10. Why? Because you can use 1, 2, 3, 4, 5, 6, 7, 8, or 9, or 0. So that is 10 different digits. Multiplied by, again, how many possible digits can I choose from?
2.
10. Okay? So we're multiplying our possibilities. So if I just made license plates using 1 letter followed by 2 numbers, there would be a total of 2,600 possibilities.
That scared me.
Then, if I'm using 1 letter in my license plate, does it have to come first?
No.
Where else could it go? Could go in the middle. You could have number, then letter, then number. So guess what? You have another 2,600 possibilities because this is 10 times 26 times 10. Okay, is there any other way I could arrange these? Also could be number, letter. So that's another 2,600 possibilities. So if I was making license plates with just 1 letter and 2 numbers, there are a total of 7,800 different combinations. Now, what if I use 2 letters? How could I write them? Or how could they be?
Letter.
I could have letter, number. Okay, so how many different letter options do I have? 26. Multiplied by how many options do I have for letters?
26.
Another 26 multiplied by how many options do I have for digits? 10. So that's a total of 6760. Is there any other way I could put 2 letters in 1 number? How else? Letter, number, letter. So that's another 6760. And is there any other way I could arrange them? number, letter, letter. So that's another 6760. Are there any other possible ways to arrange
No.
2 letters, 1 number? Nope. So that is a total of 20,280. And that's if I use 2 letters and 1 number in my license plate. Now, what if I use 3 letters? That would have to be arranged letter, letter, letter. How many options do I have for the first letter? 26. How many options do I have for the second letter? 26. How many options do I have for the third letter? 26. Okay? Multiply these all together, and that is 17,567. Now, is there any other way to arrange 3 letters? No. So again, we have a total of 17,567. What do you think you're going to do with these numbers? Add them all together. So if you add up all of your options, this is a total of 45,647 different license plate combinations. And that's just using 3 spaces, using at least 1 letter.
I always wondered how they do that.
So think of, literally, the state of California, we have, how many spaces are in our license plates? Technically, there's 7, okay? Some people have all letters, some people have all numbers. There's a whole different combination of some numbers, some letters, okay?
Like only 6 letters.
Exactly. So that's how you can see there's like millions of different
You
combinations.
can only have all numbers if you work for the government.
Okay, next thing we're going to go over is something called factorial.
It's like 8, 7, something.
Okay, factorial. Factorial looks like an exclamation point. Okay, so factorial is written as an exclamation point. So for number 5, you are going to solve 3 factorial. Now, this is something that you will be able to use your calculator on, okay? In fact, for this entire unit, you can use calculators, and I would like you to bring them. I do not have very many to loan out, so you should bring calculators.
Do we have to put the exclamation mark on it?
Yes. Okay? Something called factorial is this exclamation mark. So this is called, you would say this, 3 factorial. And what factorial means is you take that whole number and multiply it by every whole number below it. Okay? So 3, in this case, times 2 times 1. What is 3 factorial? 6. That's your answer. Now, they're not all going to be that easy. Okay? What if I gave you one that's a little bit more difficult? For number 6, I would like you to find 5 factorial. So 5 factorial is 5 times 4 times 3 times 2 times 1. You multiply that together, what do you get? 120. By the end of your homework tonight, or this weekend, you will probably have memorized up through 6 or 7 factorial. Okay, these are something that you will use a lot. Okay, it's kind of like when you you memorized all your squares and a lot of your cubes and stuff. Just because you use them a lot, you will eventually get these memorized. Okay. For number 7, now unfortunately, you are rarely going to do just factorial like this. So no, there will be no factorial facts. Okay, factorials will be in equations. So something like 7 factorial divided by 5 factorial. 7 factorial divided by 5 factorial. Without a calculator. I want you to do that. Without a calculator. Now, for those of you that are complaining, I'm going to show you just how easy this really is. 7 factorial, no, you don't need to remember 5. 7 factorial is really 7 times 6 times 5, 4, 3, 2, and 1. Now, I don't want you to actually multiply that up. Divided by 5 factorial is 5 times 4 times 3 times 2 times 1. So what happens here? The 5, 4, 3, 2, 1 goes away. It cancels itself out. So really, this is just 7 times 6. It's just 42. Okay? So this is where a lot of you that do not like showing your work here is actually helpful. Okay? Because it shows you that this really is not that difficult at all. Okay? Showing work is actually good. Now, let's try another one for number 8.
Yeah, it is.
Hard to get.
For number 8, I want you to try 9 factorial divided by 3 factorial, 4 factorial. 9 factorial divided by 3 factorial, 4
Can you
factorial.
just go 4, 3, 2, 1 instead of 3 and 4?
So this one on the top, the numerator is 9, 7, 6, 5. Now, Amanda already saw that 4, 3, 2, and 1 is going to be able to cancel. So I'm just going to write 4 and below. Okay? In the denominator, yes, we're going to have the 3, 2, 1. And we're also going to have 4 multiplied by everything below it. So yes, the 4 and everything below it is going to cancel. What else cancels there?
Then nothing. Oh, the
nine
2 and the
The
6.
6.
Can you do the cross dance?
Let's think about this.
The 9.
3, 2, 1. 3 times 2 times 1 is what?
6.
6. So just cancel out the 6. There's no need to reduce. Just cancel it out.
That's 2.
So really, we're just multiplying the 9, 8, 7, and 5. Now, I expect you would probably need a calculator to do this, and that would equal 25, 20.
Did you ever write it down?
Yes. So, this stuff is not as difficult as it appears to be if you show the work and cancel things correctly. Okay, so try to show work and cancel things
Are
correctly.
you gonna start adding like
How many examples are there?
16. Okay, let's try another one for number 9. Okay, we're going to move on to, from factorial, we're going to, okay, listen. We're going to move on to combinations of letters. So I would like you to find all the possible arrangements. Find all the possible arrangements of the letters. Guys, stop. Find all the possible arrangements of the letters C, A, and T. Find all the different possible arrangements using those 3 letters. So automatically we know we could have CAT. How else could these letters be arranged? ACT,
TAC.
okay, TAC.
CTA.
Now, instead of just randomly keep going, let's think of a little bit of a system here.
Put
Right?
one number in front.
If the letter C is in front, we could have CAT, or you could have what? CTA. Any other combinations with C being in front?
ATC.
With C being in front?
Oh.
No. What about if A is in the front?
C.
ATC. Any others?
TCA.
Okay. And finally with T in front, T, C, and A. So you can write them all down. That's great. Or, what's the first thing I showed you?
There's 3 letters.
The fundamental counting principle. So if you have 3 possible spaces, how many possible letters could go in your first space?
2.
How many possible letters? How many letters do I have to choose from?
3.
3. If I've used one of them, how many letters do I have to choose from in the second spot? 2. And then how many letters do I have to choose from in the third spot? 1. Multiply that
I
together.
don't get that though.
That's 6. Or you can realize this is 3 factorial, which is 6. So 3 different ways to do this. Now, could you just write them all out? That's fine. But on the next example, I'm going to ask you for 7 letters. Do you really want to write out all the possibilities?
6, 5, 4, 3, 2, 1.
Hold on, I'm going to show you. Calm down. So, my point here is use the spaces when possible because it makes sense, okay? How many choices do you have? You have 3 to choose from. If you've used 1, then you have 2. If you've used 1, then you have 1. So, use the different ways that I've shown you how to do this, okay? It makes life a lot easier. Try another one for number 10. Again, I want to figure out how many arrangements, and we're going to call these unique arrangements because that means that they're different. Okay, how many arrangements can be made using the letters J, U, S, T, I, C, and E?
Justice.
Irony.
three different ways you could do this. You could start writing out all the arrangements, okay? But I'm guessing there's going to be a lot. Or you can use the fundamental counting principle. I could write out my 7 spaces. 1, 2, 3, 4, 5, 6, 7. So if I just say all these letters are in a bag, okay, I pull one out. How many different possibilities are there for the first one? 7 choices. If one's gone, how many choices do I have left? 6,
Do you really have
5,
to say that? Yeah.
4, 3, 2, and 1. Or this is the same thing as what? 7 factorial, which is equal to what? We did it earlier. 5,040.
So basically, we just count down. We have to memorize what things
No,
are.
we didn't because we crossed out all that stuff.
It'd be helpful if you memorized.
Okay, so
That's all.
this is when we're dealing with letters. Now, unfortunately, sometimes letters repeat. So if you have something with arrangements with
Imagine when it's like 10.
repetition. Okay, arrangements with repetition. So for instance, what if I gave you the letters T, A, and T?
Topped. Tapped. Topped.
How many different arrangements can you make using those letters? Well, obviously I can do T, A, and T. A, T, T.
That's all you can do.
T, T, A. Any others?
Topped.
So there's 3. Now, I'm going to show you that there's actually a formula for this. And the formula is the total factorial divided by each repeat factorial. So for this one, you would use the total number is 3 to choose from, divided by how many repeats do I have?
2.
2.
Oh,
So 3 factorial divided by 2 factorial, that's really 3, 2 and below, over 2 and below. That would cancel out. So your answer is 3.
how did we come up with this ridiculous number?
Okay?
A lot of time figuring this out.
Now, for number 12, okay, same thing. I want to know how many unique arrangements, can be made using the letters H, U, B, B, U, and B. Now, I probably don't want to write these all out, okay? So let's go ahead and use this formula that I just showed you, okay? What's your total number? 6 factorial. Divided by, how many repeats do you have? No. For the B's, you have 1, 2, 3 of them, so 3 factorial. But you also have U's. You have 2 U's, so 3 factorial
2.
and 2 factorial. Now, do you think that 3 factorial multiplied by 2 factorial is going to give you 6 factorial?
No.
No, it's not. So when you work this out, this would be 6, 5, 4, 3 and below, divided by 3 and below, as well as 2 and 1. So the 3 and belows cancel out. What else can I do?
The 2 and the 4.
The 2 and the 4 can reduce. So really, we're multiplying 6 times 5 times 2, which gives us what? 60 different possibilities. So there are 60 unique arrangements using just those letters. Remember, unique arrangements means different arrangements. Okay, so different looking. Okay, next thing we're going to go over is something called permutations. Okay, there's a formula that you need to have memorized, and you need to memorize for permutations. Okay, and the formula is, or the definition is NPR is equal to, and this N and the R are like subscript. So NPR is equal to N factorial divided by N minus R factorial. I'm going to show you how we use this in just a second.
Are those supposed to be smaller than the P?
Yes, these are supposed to be subscript. So they're below. They're not on like the same level. So the way we use this is your instructions are going to ask you to find the number of permutations. Find the number of permutations. Okay, permutations are basically just how many different possibilities there are. Okay, so for number 13, if I give you 7p5, 7p5. Now, the n here stands for, the 7 is the n, which is the numerator. So if we plug this into that formula, you always take the first number factorial, so 7 factorial, divided by the difference between the two. So 7 minus 5 factorial. So if we work that out, that's 7 factorial divided by 2 factorial. If you write that all out, 7, 6, 5, 4, 3, 2 and below, divided by 2 and below. Anyone have any ideas what that actually is? It is a big number, yes. This will actually be 25, 20. Okay, 25, 20. 25, 20. Okay, whoa, we're not done yet. What is our questions? Did we have a question? Okay, I shouldn't hear a bunch of talking right now, guys. Now, I would expect that you would probably need a calculator for that. Okay? Let's try another one. Again, I want you to find the number of permutations for number 14. Find the number of permutations. If I give you 9p6. 9p6. Now, another way of looking at these numbers is that your first number is the number you start with. Okay, or the amount that you start with. The second number is how many blanks you have. So basically, this would be something like if I said I have 9 different letters in a box. Okay, I'm going to figure out how many different combinations of 6 of them could I make. So you could write this out with 6 blanks. So 1, 2, 3, 4, 5, 6. Say I have 9 different things in a box. How many different possibilities do I have for pulling out the first one? 9. If I took 1 out, how many possibilities do I have for the second letter? 8. Then what? 7, 6, 5, and 4. Do I keep multiplying by the 3, 2, 1?
Oh no.
No, because I only have 6 blanks. This is the same thing as 9 factorial over 3 factorial. Okay, so the first number divided by the difference between the two. So if you work this out, this would be, let's see, 9, 8, 7.
Wait, why do you have 3?
Because you take the number, the difference between them,
Oh,
so
okay.
subtract them, factorial. Divided by 3 and below. So the 3 and below cancels out. If you multiply all that together, we got 60,480. 60,480. You will get very, very, very large numbers with most of these things. Okay, almost done. Number 15. I want you to find 8p3. 8 permutation 3. So we're just practicing how we do these permutations. So 8p3 means you could either do 8 factorial divided by 3 factorial. So that would give us what? Now, remember, oh, excuse me, I'm sorry. This should be 8p5. I'm sorry. I'm sorry. 8p5. 8p5. I'm sorry. 8p5. So that means that the difference between 8 and 5, that's why we get a 3 on the bottom. I'm sorry. So if you write this out, this is 8, 7, 6, 5, 4, 3 and below, divided by 3 and below. The 3 and below cancels out.
So wait, the 3 factorial is the difference between the 8 and 5?
The denominator is the difference between the two. So subtract them, factorial. Okay, so always the first number factorial on the top divided by subtract them, so the difference between them, factorial. You multiply this all out, you should get 6720. Okay, 6720. Okay, and then the last one we're going to do for number 16. Number 16 is 4p4. 4p4. So if you work this out, this is 4 factorial, so always the first number factorial, divided by, what's the difference? What's 4 minus 4? 0 factorial. Now, 0 factorial is equal to 1. Okay? So 4 factorial is 4 times 3 times 2 times 1 divided by 1. So if you multiply that out, what do we get?
Oh, you're talking to us. You cross the ones out.
24.
24. Does it matter if you cross the ones out? We're just multiplying by 1.
Never mind.
Okay, so technically, if you have NPN, okay, if you have the same number here, it will always equal that number factorial.
But
Okay, now, make sure you write this down. Your homework, you are doing worksheet 1, that's in your green book, numbers 1 through 12. Okay, worksheet 1 in your green book. You are also doing, in your actual textbook, page 686, make sure you write this down because they're kind of random numbers. Numbers 3, 4, 7 through 12, 18 through 40 even, 43 to 48, as well as 55 and 56. So 3, 4, 7 through 12, 18 through 40 even, 43 through 48, and 55 and 56. That's it.